Hi, Essex, and welcome to continuation of our unit of maths, Thursday, the 28th of January. And as we go through this unit, it does contain a lot of new learning and picking up on learning that you've missed in the past. Let's start with some mathematical talk as part of our review. So we've got 3 questions here. I'd like you to read through each of them and attempt to answer them with any knowledge that you can recall from your previous work in area and perimeter. So pause the video and have a think and jot those down. Great, let's review these together. So the first question is, what is the difference between area and perimeter of a shape? I previously gave you these. They're very good. There's the area, that's the size of the surface. And down here we've got a method that's commonly used for children in year 4 and can still be quite helpful visually. Here's a formula for working out the same thing. 3 times 4 is 12. And if you count the squares there, you've got 12 1 centimeter squares. This is the non-example because this is perimeter. So if we turn to perimeter, perimeter is the distance around the shape. So rather than looking inside, we're now looking around the outside. We need to add those up. 4, 4, 3, 3, or 4 plus 3 times by 2. Here's another example. That's the equilateral triangle. 4 plus 4 plus 4, or 4 times by 3. And this is not an example because this one here is working out the area and not the perimeter. So we've got the difference. How do we work out the area and perimeter of shapes? Can you show this using a formula? Well, I think we've begun to explore formula here for area. What about perimeter? So the area of a rectangle is the length times the width. Place a triangle over 1 centimeter squared paper and see if you can discover the formula for the area of a triangle. The perimeter of a rectangle, it could be length plus width plus width. I haven't written it like that because what I have done is I've gone for length plus width and multiplied that by 2. But if you use some numbers as examples, hopefully you will be convinced that the answer is the same. This might just be just a tad quicker sometimes. What about the perimeter of a triangle? What does that equal? So we had, can you have 2 rectangles with an area of 24 centimeters squared, but different perimeters? How did you tackle this? I've had a little go myself. So knowing that that was 24 centimeters squared, I remember that if we do the factors, let's just go back a little bit. It's a bit painful doing this with the mouse. I'm going to persevere just to make it clear. So 2 times 12, 3. It's in the 3 times table. Right, thank you. 3 times 8 is 24. 4 times. Excellent. 4 times 6. 5, no. 6, we've already got. 7, no. 8, we've already got. 9. 9? No. 10? No, can't be. 11? Nope. 12? Yep, we've already got that. So these are the factor pairs. So 4. I've got 1, 2, 3, 4. That hopefully correspond to these. Is this all the possible rectangles? What are the area? Now the area, we know we have the formula. I also put them on squared paper so you can count. So hopefully if I've got this right, and I would advise you to check, if you count the squares, each one has 24 squares. Now, if we label that side and that side, so 2 times 12, we could work it out mathematically. Now, once you've labelled them, you then can find out the perimeter. So what's the perimeter of that one? Okay, yeah, that's one way of doing it. 12 plus 12 is 24, plus 2 is 26, plus 2 is 28. How else could we do it? Yep, that's right. So 12 plus 2 is 14, multiplied by 2 is 28. Can you have two rectangles with an area of that but different perimeters? What do you think? Look at the shapes below. A couple of questions. Do any of the shapes have the same area? So this is the space in. Do any of the shapes have the same perimeter? And the perimeter, of course, is the total length around the outside. So pause the video, work through each of those. I recommend you label them. So maybe A, B, C, D. In fact, if you do it like that, because when we go through my thinking, that's how I've done them. So pause the video and work through that explore example. Great, let's review your thinking and my thinking. Follow very carefully in case I've made any errors and you need to correct me. I'm thinking here, area 2 times 12, 24. Perimeter 12 times 2, 12, you're right, 12 plus 2 multiplied by 2. So 12 plus 2 is 14, correct? Multiplied by 2 is 28. What about the area this time? Yep, 6 threes, 18. Notice the square here, the indice to the power of 2. Perimeter, 6 plus 6 plus 3 plus 3, 18. 6 plus 3, 9 times by 2 gets the same answer, 18. 2 nines, 18. Perimeter, 11 times 2, There we go. What about this one? How are you going to do this? Who can explain that one? This is my thinking. Does this correspond to your thinking? So if that had a nice straight line, we've got 9, and then this line would be 9 and 1 and 1. So that would be 1 there. And this whole line would be 9. Which means this is 7, this is 1. So what's this? Yeah, it's 7. Because the other one's up there, isn't it? Have a look. If I've drawn this correctly, and I'm assuming that these are 1 centimetre squared, if I've drawn this correctly, have I then got the answer correct? Okay. Thinking about this, do any of the shapes have the same area? Yeah, they do. C and B. Do any of the shapes have the same perimeter? Doesn't look like it. Not from my calculations. That one there's fascinating, isn't it? It's got the same 18 and 18. How did you do? Pause the video and have a think. Look back through it. So explore these. Work out the missing values. Pause the video and see if you can work them out. This is how I've approached it. The first thing I was thinking was, I know that 1 centimeters is equal to 10 millimeters. And why was that? It was because I noticed this in both of them, the different units of length. So if I take this one, I know that area is length times width. So 12 times something equals 60. 60 equals 12 times what? Well, here's the inverse. So 60 divided by 12, 5? What do you think? Same formula. Area equals length times width. Don't know the area this time. So the area equals 100 times 60. 100 times 60 millimeters. But I need the answer in centimeters. Ten times 6, 60. How can they have the same area? Can you explain that for me, please? Have a go. Draw and label another example in this sequence. And just like these, don't draw them to scale. Pause the video, have a go at those 2 questions. Make any corrections. Checkpoint. So this will just check your understanding, and it will help you decide where to start the maths lesson, the independent stage of the maths lesson. We have area, and then these are just labelled y and x. So rather than having numbers, it's just a generic xy. It's quite common. And area equals xy. So what that's really saying is area equals x times y. Now, I've been saying to you length times width, which is almost in this the way they've labelled it y times x, but we know Tom, that this is? Yeah, commutative. Thank you, Tom. And then it gives these. True or false? Please explain. So it is true. Just going back. It is true that the area equals x times y. And if you want to find out this, which is the width equals the area divided by the length. And if you want to find out y, the length equals area divided by the width. And the suggestion is that you do it with numbers. And there was an example when we were in the Explore, so you could always go back and have another look at that. But take some time, review these, ensure you know why that is true. Complete as many questions as you can. Start at either step 1 or step 2. The printable or easier to read versions that you can have on your screen will be on Dojo, answers for self-reviewing and marking on Dojo. And the guide time for a maths lesson is approximately an hour. So if you take the time that you've spent on it with me, which would be the length of the video plus all the pause time, you've already done quite a lot of maths and quite a lot of thinking. Build it up to an hour or so, and then the flashback for today is, in addition, the flashback for takes anywhere between about 5 and 15 minutes. These are the questions that you can do in each step. Okay. Some of you, I'm hoping, particularly started on step 2, and it was all rather straightforward. Here's some reasoning and problem solving. So there's one question here, one question there. Okay. Excellent. Well, enjoy today's maths year 6. Any questions? Of course, talk in your learning groups. Do send me a message. I'll be very happy to help, and I will try and arrange a support group at a convenient time. Take care. The answer for that one, and the answer and advice for that one.